Hello, welcome to A1 Tutor live class and welcome to physics class. Oh, really? Is this the first time that you are watching our video on YouTube? Please take the time and subscribe on our YouTube page. Subscribe. If this is the first time that you are watching our video on YouTube, do well to subscribe so you can be getting notifications of our videos anytime we post our videos. Okay? Do well also to like, share, and comment. In this video today, we are going to be learning solving of question under the topic elasticity. And those questions are going to be basically the UTME questions, So we're going to be solving UTME questions that is captured under the topic elasticity. Elasticity. Join with me as we start solving UTME question on elasticity. Permit me to make use of my whiteboard. Like I said, we are going to be solving UTME questions today. In our live class, we'll be solving UTME questions on the topic elasticity. Solving solving UTME question on elasticity. Elasticity. So this is what we concentrate today. We'll be solving numerous questions on the topic elasticity. I'm going to identify where exactly the question were picked from. We're going to solve and we are going to pick the correct response from the given options. All right, let's start with the first question. What is the first question we have? We have the first question from UTME 2021. UTME 2021. From UTME 2021, we have the first question. UTME 2021, we have the first question from there. If a load of mass 10 Newton, if a load of mass 10 Newton, load of mass 10 Newton stretches a cord by 1.2 centimeter, stretches a cord by 1.2 centimeter. What is the work done? What is the total work done? What is the total work done? Now, we're going to solve this question, but I want to give you a hint. And what is the hint? Is that you always write out the parameters you have in the question. That will help you to know the appropriate and accurate formula to use. Solution. I was given a force, which is 10 Newton. That is the load of mass. And I was given the extension of the cord. The extension of the cord, which is letter E, is given as 1.2 centimeter. And I'm asked to find the work done, which is W equals to question mark. So we need to get the total work done. The total work done. But before we proceed to solve that, let's take note that our extension cannot be measured in centimeter. We have to convert it to meter because in physics, length is considered to be measured in meter. So how will I convert 1.2 centimeter to meter? 1.2 centimeter to meter. We're going to have it as 1.2 divided by 100. The reason why we are divided by 100 is because 100 centimeter make 1 meter. 100 centimeter make 1 meter. 100 centimeter make 1 meter. So 1.2 divided by 100, that is 0.012. 0.012. So the extension is now given as 0.012 meter. That is the value of the extension now. So work done in an elastic material is given as 1 over 2 Fe, where F is the force and E is the extension. So work done will now be equals to 1 over 2 times 10 Newton times the extension, which is 0.012. Okay, we'll proceed to multiply this. If 2 cancel 2, we have 1, and 2 in 10, we have 5. So we have work done to be equals to 5 times 0.012. W equals to, we need to multiply that together, multiply this value together. Multiply the value together. When you multiply this and this together, that is 5 multiplied by 0.012. 5 multiplied by 0.012. The answer is 0.06, which you can also express as standard form. This is in decimal form, joule, and in standard form is going to be 6 multiplied by 10 raised to power minus 2 joule. By moving the decimal points from this place, 1, then 2. So I move it twice. That is why the index is minus 2. That is why the index is minus 2. Now let's examine the options. Is option, what we have here is 10 raised to power minus 2, 10 raised to power minus 2. So you don't need to be confused. It's exactly 10 raised to power minus 2 that we have in the options. So is it the first option or the second option or the third or the fourth option? It is option A. Option A is 0. Option A is 6 times 10 raised to power minus 2 joule. So option A is the correct answer. Option A is the correct answer. Now let's go on to take the next question. I believe this solution is clear to us. This solution is clear to us. All right, so we can move on to solving the next question, which is question number 2 on elasticity. Question number 2 on elasticity. Peradventure, you're on YouTube and this is the first time you are watching our video, you are free to ask questions in the comment section. So while watching this video, if you have a question, do well to drop it in the comment section on our YouTube page. Number 2 question now. I'm going to wipe the board. So we'll move on to question number 2. So question number 2 now, we have UTME question 2015. UTME question 2015. UTME question 2015. And this is the question. Okay. So we have UTME question 2015. A piece of rubber 10 centimeter long, a piece of rubber 10 centimeter long, 10 centimeter long, stretches 6 millimeter when a load of 100 Newton is hung from it. When a load of 100 Newton is hung from it. And the question is, what is the strain? What is the strain? So here, we are going to be solving for the strain. We're going to be solving for the strain. First thing is to write out your parameters and do the conversion if necessary. The first value we are given is the length of the rubber. Length is small letter L, which is 10 centimeter. Extension, that is the rubber stretches 6 millimeters, so the extension is 6 millimeter, and the force given as F is 100 Newton. 100 Newton. So we don't actually need the force. What we need is the length and the extension, because we have to calculate strain. Strain is equals to extension over original length. Extension over the original length. Now, how will I convert 10 centimeter to meter? That is by dividing 10 by 100. That will give us 0.1 meter. How will I convert 6 millimeter to meter? That is dividing it by 1,000, because 1,000 millimeter makes 1 meter. 1,000 millimeter makes 1 meter. So we have 6 divided by 1,000. That is equals to 0.006 meter. Take note, I said 1,000 millimeter equals to 1 meter. So that is why we use the conversion. And also we have 100 centimeter is equivalent to 1 meter. Now that we have the length in meter and the extension in meter, we can go ahead to solve for the strain. The strain is now 0.006 divided by the length, which is 0.1, and that gives birth to the final answer, which is 0.06, 0.06, or in standard form, what should be the value in standard form? If I have 0.06, if I move the decimal point 1, 2, that should be 6 times 10 raised to power minus 2. 6 times 10 raised to power minus 2. 6 times 10 raised to power minus 2. That will be the answer for this question. Examining the options given to you, we have option 1 is raised to power 3. 6 times 10 raised to power 3. We have 6. We have 60. We have 6 times 10 raised to power minus 2. So this option D will be the correct answer. The answer is option D. 6 times 10 raised to power minus 2. 6 times 10 raised to power minus 2. Now, let's take the next question, which is question number 3. Of course, if you have question on this also, ensure you drop your question in the comment section while watching the video on YouTube. If you are watching the video on YouTube and you have a question based on this, do well to drop your question in the comment section. We are taking question number 3 now. Question number 3. Question number 3. Question number 3. question 3, we have this question from UTME 2014. UTME question 2014. UTME question 2014. A force of 500 Newton, a force of 500 Newton is applied to a steel wire of cross-sectional area 0.2 meters square. The tensile stress is dash. So we have from the question, we are given force, which is 500 Newton, and we are given cross-sectional area, which is 0. Cross-sectional area, which is 0. Cross-sectional area is 0.2 meters square, and we are asked to find the stress. Stress is equals to force divided by area. Stress is equal to force divided by cross-sectional area. So the force is 500 Newton, and the area is 0.2. Dividing this together, we are going to get the value 2,500 Newton per meter square. Newton per meter square, that is 500 divided by 0.2 is 2,500 Newton per meter. It is Newton per meter because force is measured in Newton and the cross-sectional area is measured in meter square. So this is expressed as Newton per meter square. That would be the unit. Newton per meter square. So this will be the answer. So let's check the options. We have 1.0, no. Now you can see that the answers were given in standard form, which requires that your final answer also should be written in standard form. And 2,500 in standard form, there's an invisible decimal point here. Moving it, 1, 2, 3. We stop here. That is 2.5 times 10 raised to power 3 Newton per meter square. So this will be the answer. So let's check the option. Option A, 1.0, that is not the answer. Option B, 1.0, that is not the answer. Option C, 1 is 2.5 times 10 raised to power 3 times 10 raised to power 3 Newton per meter square. Newton per meter square. So option C is the answer. That is 2.5 times 10 raised to power 3 Newton per meter square. So the correct response is going to be that question, that option C. Option C will be the correct response for this UTME question. All right. So this is going to be the final answer. And I will always advise you that when you solve a question, always check the option to be sure of how to leave the final answer, either in decimal point or in fraction or in standard form, because the answer can be, the options can be in standard form and your own final answer can be in decimal. So you will need to convert it back to what? To the standard form. You will need to convert it back to the standard form. So you have to take note of that very well while solving question in the UTME. Always take note of the options. That will direct you on how you are going to present the final answer. So for this question I will solve, the final answer was 2,500 Newton per meter square. But looking at the options, we notice that the options were given in standard form. So I had to convert my final answer, which is 2,500, to standard form. I hope that is clear to us. Now let's move on to take the fourth question under elasticity. Fourth question. The fourth question. Question number 4. Let's check the UTME question we'll be using to solve question number 4. Question number 4. We have to solve this question. Question number 4. We have a UTME question 2013. UTME question 2013. UTME question 2013. UTME question 2013. Let's go through the question together. Calculate the work done when a force 20 Newton stretches a spring by 50 millimeter. Stretches a spring by 50 millimeter. So we are asked to find the work done for that particular question. The work done for this particular question. We are given the force to be 20 Newton and the extension, which is the stretches, E extension equals to 50 millimeter, which we are going to convert first before we can use. The conversion of 50 millimeter is required. 50 millimeter, which is 50 over 1,000, will be equals to 0.05 meter. 0.05 meter. So since we are asked to find the work done, W, which is work done, is 1 over 2 Fe, 1 over 2 multiplied by F, which is 20, multiplied by E, which is 0.05. We have 2 here, 1, 2 in 20, that is 10. The work done, W, is equals to 10 multiplied by 0.05. 0.05. Multiplying that together, 10 multiplied by 0.05 will give us 1 over 2. Work done equals to 1 over 2 joule or 0.5 joule. Work is measured in joule. So it is very important that you add the SI unit, which is joule. The final answer is work equals to 0.5 joule. So you can see that the answer given, all the options are in decimal. So I cannot consider 1 over 2. I'll be considering the decimal part, which is 0.5. Checking the options. Option A is the correct answer. So A is the correct answer. 0.5 joule. 0.5 joule is the correct response. So we are moving on to the next question. I believe this is totally clear to us. And if perhaps you have a question, do not hesitate to drop your question in the comment section. Do not hesitate to drop your question in the comment section. So we've solved question 5. Let's go question 4. Let's go on to solve question number 5. Permit me to wipe the board. So question number 5. Question number 5. So question number 5 is UTME question from 2012. A UTME question from 2012. 2012, if a load of 1 kg, stretches a cord by 1.2 centimeter, what is the force constant of the cord? Take G, which is acceleration due to gravity, to be 10 meter per second square. 10 meter per second square. So we are given in the question the mass of the load, which is 1 kg. We are also given the extension, letter E, the extension which is given as 1.2 centimeter, and we are given G, acceleration due to gravity, as 10 meter per second square, as 10 meter per second square. Now to get the constant force, which is letter K, we have unknown. K, which is constant force, equals to force over extension. So we need to get force because in all these parameters, force was not given. How will I get the value of force? F equals to mass times acceleration due to gravity. The mass is 1 times the acceleration due to gravity is 10 meter per second square. We have 10. Multiply the two together. We have the force equals to 10, which is also 10 Newton. The force equals to 10 Newton. Substituting the value of force, we have 10 over the extension, which is E. But you have to convert 1.2 centimeter to meter, which is going to be 1.2 divided by 100. 1.2 divided by 100. 1.2 divided by 100 divided by 100. That gives us 0.012 Newton per meter. So we've gotten the force, we've gotten the extension to be this value. Now let's get K. K is force, which is 10 over the extension, which is letter E, is now 0.012. 0.012. K equals to dividing 10 by 0.012, dividing 10 by 0.012, we have 6. Dividing value 10, dividing 10 by 0.012, we have 833.333. So approximately to the nearest whole number, according to the options, we have 833. 833 Newton per meter. 833 Newton per meter. Checking the options, option A happens to be the correct answer, while others are not the correct answer. So this is going to be option A. Option A will serve as the correct answer. Option A will serve as the correct answer. Now this is question number 5. We're going to take 2 or 3 more questions to this. 2 or 3 more questions to this. I hope this is perfectly clear to us? I hope we understand this. And if perhaps this is not clear to you, you can do well to drop your question or drop your questions in the comment section. Now we're going to move on to question number 6. But before that, let's take a pause. Have you been looking for a way to prepare for your WAEC, NECO, JAMB, probably BESE, without making use of hard copy past questions? Okay, now this is for you. You can make use of A1 Tutor app on Apple Store and Android, which is Play Store. A1 written like this, A1 Tutor app is both on the Android. We have it for Android and also for iOS. So you can have it on your Play Store, or your Apple Store. So you have the app available on those two, Play Store and Apple Store. So you can do well to download and have access to unlimited past questions with answers and accurate and validated explanations to the answer. You have access to that. Not that alone, on the app also you have access to live classes that will be coming up subsequently. You also have access to video lessons that explains every subject, the topics in every subject, detailed with pictures and so many things that will make it easier for you to understand. Also on the app, you have access to lesson notes well structured and well presented. All these at no cost, meaning that when you download the app, you have no payment, no subscription, no hidden charges, no hidden fees. So just download the app and start using it. You have categories that you can subscribe, you can actually register for, either the senior category or the junior category or the A-level category. So this app is free. So I don't know what is actually keeping you waiting not to have downloaded it. So you can do that right away. Go to the Play Store app or go to the Apple Store app and download A1 Tutor app. Okay, thank you. So let's move on to the next question. That is question number 6. Question number 6. I'll be I'll wipe the board so I can have the next question on my screen. Question number 6. Question 6. Now let's check what we are going to have for question number 6. We have a UTME question from 2011. A UTME question from 2011. So here is the question, and we are all going to solve it together. So we have UTME question 2011. UTME question 2011. Let's examine the question together. A copper wire was subjected to a tensile stress. Underline the word tensile. Tensile stress 7.7 times 10 raised to power 7 Newton per meter square. Calculate the tensile strain of the wire. Given that Young modulus is 1.1 times 10 raised to power 11 Newton per meter square. Parameters in the question, we have the tensile stress value. So let's write stress, that is tensile stress, is given to be 7.7 times 10 raised to power 7 Newton per meter square. 7.7 times 10 raised to power 7 Newton per meter square. Also, we are given the Young modulus value, the Young's modulus, given as 1.1 times 10 raised to power 11 Newton per meter square. And what is the question? Find the tensile strain. Find the tensile strain. So to get the value of the tensile strain, which is question mark, the value is unknown. Now, how do we get the tensile strain? Just make use of the formula of Young modulus. Young modulus represented by letter Y is equals to stress, that is tensile stress over tensile strain. Tensile stress over tensile strain. Now, if your Young modulus is having a denominator of 1, I'll cross multiply. Then I'm going to have strain, tensile strain, Y equals to stress. And the aim is to get the tensile strain. So let me divide both sides by letter Y. I'm going to have the strain, tensile strain to be equals to the stress, tensile stress over the Young modulus value. So the tensile stress is given to be the tensile stress. The tensile stress is given to be 7.7 times 10 raised to power 7, all divided by the Young modulus value. The Young modulus value is given to be 1.1 times 10 raised to power 11. So solving this, you're going to have 7.7 divided by 1.1 times 10 raised to power 7 divided by 10 raised to power 11. 7.7 divided by 1.1 divided by 1.1, that will give us 7. 7 multiplied by, using the law of indices for these two index, we're going to have 10 raised to power 7 times 10 raised to power, or probably change it to minus. The law of indices states that the division changes to minus of the exponents. So this will be 7 minus 11. 7 minus 11. That is going to be 7 times 10 raised to power, subtracting 11 from 7, that is minus 4. So the tensile strain, the tensile strain is given as this value, which is 7 times 10 raised to power minus 4. And the tensile strain does not have a unit. So this will be the final answer. Checking the options, we have option A to be the correct answer, while others are wrong. So option A is the correct answer for this question. Option A is the correct answer for this question. I hope this is clear to us and we do well understand what I've explained. I hope so, that we understand what I've explained now. If perhaps you are watching this video on YouTube and you have a question, probably why the solution was going on, you are not getting a part of it, do well to drop your question in the comment section. Do not hesitate to do that. All right. So we're going to take the next question. That is question number 7. And the last question, which is going to be question number 8, is going to be an evaluation question for us to solve. It's going to be an evaluation question for us to solve. So let's go ahead to pick the next question. Question number 7. Question number 7. All right. Question number 7 now. Question 7. Let's say the UTME question that I'll be having. All right, we have a question from 2010. 2010. We have a UTME question from 2010. And we're solving that together. 2010 UTME question. And this is the question. Okay, now let's solve the question together. UTME 2010, if a wire 30 centimeter long, so we have a length given, is exacted to 30.5 centimeter, that is the final length after extension, by a force of 300 Newton, find the strain energy of the wire. Find the strain energy of the wire. Take note, the strain energy of the wire is synonymous to the energy stored in the wire. It's synonymous to the energy stored during the process of extension, during the process of what? Elasticity. So we have parameters given in this question. We have the length, let's say L, to represent the original length, the original length given to be 30 centimeter. Now we have L1 representing the new length after extension, the new length given to be 30.5 centimeter, 30.5 centimeter. And also we are given the force that acted. The force is given to be 300 Newton. 300 Newton. And we are asked to find the energy stored, which is equals to 1/2 KE squared. 1/2 KE squared, which implies that if I'm going to solve this question, I need K and I need E, and both were not given in the question. But we are given prior informations that will make us to have those values. So let's go ahead to get E, obtaining E. E, which is extension, is equals to the new length minus the original length. The new length is 30.5 minus original is 30. Subtracting this, you have 0.5 centimeter, which you still need to convert to meter. Please take note, because when you are even using centimeter, one thing about JAMB is that you are going to see the answer inside the option, and you will think you are right. No. Okay? Always take note that when you are dealing with length in physics, it is always measured in meter. So whatever you are given, whether kilometer, whether centimeter, whether millimeter, you have to convert it back to what? Meter before you solve the question. If you use it that way, you're going to get an inaccurate answer. So I need to convert this by dividing 0.5 with 100. And when I do that, I have the value. 0. I have 0.005, 0.0005 meter. Let me write it properly so you can see. Is equals to 0.005 meter. Now I've obtained the value of E. Now I need to get that of K. How do we get the value of K? Obtaining the value of K. K equals to force over extension. So K now equals to the force, which is 300 Newton, divided by 0.005. And when you do that, your K should be equals to 60,000. Your K should be equals to 60,000. So if K equals to 60,000, now we can get the value of the energy stored. We have K, we have E. So we can solve for the energy stored. Energy stored is equals to 1 over 2 Ke square. 1 over 2 is the same thing as 0.5 multiplied by 60,000 multiplied by E. What is E? The value of E is 0.05. This is the value of E, 0.005. Then all square. Simplifying this, multiplying this, 0.5 times 60,000 times 0.05 all square, you're going to obtain the value 0.75 joule. 0.75 joule. 0.75 joule. So observing and examining the options, option A is not correct. Option B is not the response. Option C is not the response. Option D is the response. So the answer is option D, which is 0.75 joule. 0.75 joule. That would be the correct answer. That will be the correct answer. I hope this solution is detailed enough for you to understand, but perhaps you still have a question, or probably you came across a question under elasticity which you cannot actually solve. Do well to drop it in the comment section. We will attend to it, solve it, and send you back the response also through the comment section. All right. Now I'm going to give us our own question. The question will serve as an evaluation for us to see if we are able to also solve a question from UTME. I'm going to drop the question. You are all going to solve the question. If you are watching me, if you are watching this video right away, the question is for you. Solve the question and drop your answer in the comment section. We really appreciate to have your answer in the comment section. Let's get to the question now. That is question number 8, which is served as an evaluation question. Permit me to wipe the board so we can have the evaluation question pasted. Okay, so the evaluation question, that is still going to be from a UTME question 2010. 2010. So this is the question. I said it is an evaluation question. I want you all to solve it. Evaluation. So I want you all to solve the evaluation question. If you are watching us on YouTube for the first time, this is what we actually do to engage you and also to get a feedback of our videos. So we want to be sure that you understood what we've done in this video. So this question is for you. You're going to solve it and send your response via the comment section on YouTube. Feel free to drop your answer. So you have to solve, and drop your answer in the comment section. So you're going to solve this question and drop your answer in the comment section. Thank you so much for your time, and thank you for listening. Thank you for following us on YouTube. All right. We really appreciate your gesture, by watching our videos and learning from our videos. Do not forget, like I said amidst the class, that if you are looking for an app to prepare yourself, or you are looking for an app to enhance your academics, to enhance your performance in school, in exams, the best app for you that I recommend for you is the A1 Tutor app. The A1 Tutor app that is available on Android and iOS. So you go there, download it, and explore the app. Is awesome. The app is awesome. It's an amazing app and very friendly interface. Very easy to what to interact with. It's free. All of this is free. You're going to have access to CBT. CBT comprises of past questions from WAHEC, NECO, JAMB, BESE, IGNB, and so many other exams. Their past questions are there, updated past questions with a long lifespan, like 10 to 15 years past questions available. You are going to solve and also have access to answers and self-explanatory responses. Now, when you take an answer and probably you are not correct, the app will suggest to you the correct answer and give you explanation of why the answer is correct. You have access to lesson notes, you have access to video lessons, and you have access to live class, all at no cost. That's amazing, right? So that's for you. Also, you can tell some friends to do well to also download the A1 Tutor app, and also tell friends to always follow us on YouTube channel to have responses to some topics that have been affecting them. We do not we provide videos on YouTube on all subjects. So if peradventure your own is to you need a video on English, definitely is available. On biology is available, on other subjects also. So you can do what to tell your friends to subscribe on our YouTube channel so they can have updates of the videos. And you too, do not forget to click the subscribe button. Thank you so much for your time. Tomorrow is another time for a live session class. Ensure you make yourself available and learn. Thank you. See you tomorrow. Bye.